Bro, what do you want? What do you want? What do you want? What do you want? What is it? All right. Today we're going to graph systems of inequalities. So before we've graphed inequalities. We've done them, but now we're going to combine them and do two at the same time to create a system. So when you ever have two or more functions graphed, you're creating a system of functions. So here we're going to graph a system of inequalities. All right, so the first one we're going to graph here is y is greater than x minus 4. So I'm going to graph that by starting at -4. Okay, that's my y-intercept. My slope, I'm going to go up 1 over 1. When I connect these points, okay, I'm going to use a dashed line. Why am I using a dashed line here? Well, to review what we talked about with graphing inequalities, if it is not included, aka not equal to, that's why we represent that using a dashed line, showing that the solutions on this line are not solutions, okay? It says y is greater than. So what we would really do is test a point on either side to see which one works. So I tested a point here below the line. This would not work. But if I tested a point over here, the values would work. So I'm going to go ahead and shade this section. You want to make sure that you're shading like this. Otherwise, the next portion will not make as much sense or not be as clear. This is going to really help make that solution be very clear for the system. All right, this next one we're going to graph, though, we can't graph initially as it is. We're going to have to change its form. So it's in standard form. To make it easier to graph, I'm going to change it to slope-intercept form. So y is greater than or equal to -x plus 2. Because if I subtract x on both sides, I'm able to move that perfectly. All right. The y-intercept is 2. The slope is -1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1 like this. Since this is equal, it's included. All the solutions on the line are included. So I'm going to make sure when I draw this line that I make it a solid line. Now, if I tested a solution, the solutions would be anything above this line. So that would include anything in this area. We're going to test a point at the end, just to be very clear, to make sure. But the reality is anything in this overlapping region of my shading is a solution to the system. We're looking for a solution to the system. Okay? So, for example, I'm going to pick the point. Let's pick a color that stands out. I'm going to pick the point 1, 2, 3, 4. 1, 2, 3, 4, 5. Let's pick this point, the point 4, 5. Based on my shading, that should be a solution to our system. So if I substitute that into either of the two equations, it should work. So let's try it out. Slide this over. When I say equation, I meant inequality because these are not equations. These are inequalities. Equations have an equal sign. These are inequalities. I'm using the original form, okay? But I'm substituting this into both of them. So this inequality is marked by red, just to be clear. And this one was marked by the blue, just to be clear, okay? But when I substitute the point into both inequalities, it should work. So the y value is 5, the x value is 4. 4 minus 4 is 0. 5 is indeed greater than 0, so this works out. We're good to go. Over here, the y value is 5, the x value is 4. When I add them together, I get 9, and 9 is greater than or equal to 2, which is true, which means it works out. So 4, 5 is indeed a solution, and this is indeed our shaded region. So we're going to try another one. The whole idea is we're going to graph them, shade, and then test the solution to make sure that it works. All right. So first thing I'm going to do is I'm going to identify this one. I want to do this one in purple this time. Make sure that you know that this is what I'm looking at. Okay. It's not the fastest way for us to graph. So what we're going to do is we're going to change the form from this form, which is actually not any specific form, but we're going to change it to slope intercept form. All right. Here the y-intercept is -3. The slope is 2 over 1, so that means we're going to go up 2 over 1. What do you notice about how the inequality is structured? How is that going to impact what we do next? Well, the first thing that's going to impact is how we create our line. We have solutions that are not included. So we are going to have to make sure that we create a dashed line. I should complete that. Remember, you want to extend the line across the entire graph so you can like really clearly see the shaded region that we're talking about. So if I test a solution, I highly recommend it. Test either side of the line. It's clear to me though that it's going to be this side. You want to be most accurate as possible. You want to be as detailed as possible. If you scribble here instead of drawing out these lines, like your solution region will not be as clear. This is the best way to make this clear. All right. So this next one is also, again, not in slope-intercept form. So we're going to have to change that one as well. I'm going to do this one in green. When I'm doing this one, something's going to happen here. Really important, something you really need to refresh yourselves about. When I divide or multiply by a negative value, it's going to flip this sign. It's a really key thing that a lot of people forget. It's a very key misconception. Gotta be very careful and make sure you don't forget that. All right, so our y-intercept here is 5. All right, so 5, which means we're going to go down 3 with our slope is -3 over 1. So we're going to go down 3 over 1, down 3 over 1. Okay, it is going to be a solid line because the values are included. They are equal to. All right, so if I tested a point on either side of this line, I would find that this side is the side that works. So I'm going to go ahead and shade. I don't need a ruler. All right, so it looks like our solution set is down here where the overlapping occurs. So we're going to pick a point over there. I'm going to pick the point. Let's pick 6, 0. Okay? So we're going to substitute 6, 0 into both of these. So we had y plus 3 is less than 2x. Okay? We also have -2y less than or equal to 6x minus 10. Let's test out one at a time. So this is our x, our y value. So y is 0. X is 6. 0 plus 3 is 3. 2 times 6 is 12. 3 is less than 12. That checks out. So we've satisfied one of the two inequalities. We need to satisfy both. Let's check it out. Negative 2, the y value is 0, less than or equal to 6 times 6 minus 10. This is 0. 6 times 6 is 36. 36 minus 10 is 26. 0 is less than or equal to 26. That checks out. That means 6, 0 is the solution to our system. It satisfied both of the inequalities. Don't only try one. You always got to make sure you try both just to be sure. And there you have it. All right, here's our next one. So I'm going to do this one in green. This is in standard form, correct, okay? And then this one is also in standard form, excellent. We have to change both of these standard forms, though, to slope-intercept form, excellent. So I'm going to do some switching around, inverse operations, but I am confident that you know how to do that. Staying with this one. So it's a little bit more complicated, so I'm actually going to write out more steps for this one. So first thing I'm going to do is move the 2x by subtracting it on both sides, and then I'm going to divide by 3. So divide by 3, you get y is less than negative 2/3 x minus 1. All right. Let's start with the green one. So our y-intercept is negative 1. Our slope is negative 2/3, which means we're going to go down 2/3. That's how our y's are going down, and our x's are increasing by 3. All right, solid or dashed? Dash, correct, because it is not included. Excellent. All right. All right, so if we were to shade this properly, that means we would shade, if I test the solution, this would be the area that would satisfy. All right, so next, we are going to test the next inequality. All right, so our y-intercept is 2. Goes up 1, 2, 3, 4 over 1 is our slope. It is going to be a solid dash line. Solid, correct, because the solution is included. Excellent. All right. All right. Excellent. So this is greater than. Okay, I know that it's going to be this side. You always got to test points, but we only want to focus on testing points for y'all right now just to see which one satisfies both inequalities. But you always, when you're graphing these, you want to test both just to make sure. All right, so now we're going to pick a point. The point I'm going to pick is going to be in this overlapping region will be negative 1, 2, 3, 4, 5, 6, 7. Let's do negative 8, 0. All right, so we're going to test the point negative 8, 0 into both of these inequalities. So it's 2x plus 3y is less than negative 3. Y minus 4x is greater than or equal to 2. Test both. So the point negative 8, 0 should be a solution. The x value is negative 8. The y value is 0. 2 times negative 8 is negative 16. 3 times 0 is 0. Negative 16 plus 0 is negative 16. Negative 16 is less than, so it checks out. All right, here the y value is 0. The x value is negative 8. All right, so when I multiply, I'm going to get plus 32, greater than or equal to 2. And 32 is indeed greater than or equal to 2. That checks out. It's a solution to both inequalities. It's a solution to the system. So therefore, this is definitely our solution to the system. That entire region. Excellent. All right, so here's our last problem. One of these is in standard form, and then the other one is already in slope-intercept form. Okay, so we gotta change this one into slope-intercept form to make it easier for us to graph. We get y is less than negative 3x plus 7. Our y-intercept is 7 then. 1, 2, 3, 4, 5, 6, 7. I'm going to go down 1, 2, 3 over 1. 1, 2, 3 over 1. It is going to be a dashed line, correct, because it is not included. Excellent. Or not equal to. Both are accurate. All right, so if I'm shading this, I'm going to test a point, and this is the side that's going to work when I test that point. Okay, for this next one, start at -4, 1, 2, 3, 4. That is our y-intercept. Go up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. All right. So this is going to be included because it is equal to. All right. And we're going to shade above. So that means this is the solution region. So we're going to test a point. I'm going to pick the origin just because it's so easy to use those values to substitute in. All right. So 3x plus y is less than 7. We're going to test 0, 0. And we're also going to test it in y is greater than or equal to 2/3 x minus 4. So both are 0. 3 times 0 is 0. 0 plus 0 is 0. 0 is less than 7. Checks out. All right, substitute in 0. And then substitute in 0. All right, 2/3 times 0 is 0. 0 minus 4 is a -4. 0 is greater than or equal to -4. So that also checks out. It's a solution to the system, which means this region is indeed correct.